Okay, today's our last section on transformation, so we're going to look at dilations. So you've probably been to the eye doctor before when your eye dilated. What does dilating do to your eye?
Changes it.
Changes it. How?
Bigger.
It makes it larger, right? And the reason that the doctor dilates your eye is so that it becomes larger and they can look in there and they can look at everything to see what they need to see. Okay? So dilation is a change in the size of the object. So since you're changing the size, is it still going to be congruent? No. It's going to be similar. And similar means that it's still the exact same size or same shape, but the size has changed. So imagine like if you put a picture into a PowerPoint presentation and you drag on the corners, it gets bigger, but it's still proportional, right? So your eye doesn't change into a square or to a triangle or anything when the doctor dilates it. It's still round, it just gets larger. It can also get smaller, okay? So there are three things that you need to look at when you're dilating, and that would be the three things that you're looking at are the scale factor. We use the letter K for scale factor. I'm not really sure why they've chosen K, but K is the letter that they've chosen. So if you dilate with a scale factor that is greater than 1, it's going to be an enlargement because you're going to be multiplying. And if you multiply by a number that's bigger than 1, doesn't it get bigger? Yeah. Okay. If the number is between 0 and 1, like 1/2 or 3/4 or 0.24, then that will be a reduction. Because if I multiply something by, let's say, a half, for instance, doesn't it get smaller? Yep. Okay? So that's a reduction. And if the scale factor is 1, there's no change whatsoever. Because if you multiply by 1, nothing changes, right? So it just remains the same. So first we're going to look at just, and I'm not really sure, here's another, I did this quick again today, which says rotate. Sorry. It should say find. Okay, so we're going to find the new coordinates. Okay? For our triangle, our original triangle has the vertices A00, B80, and C3, -2. So we want to find the coordinates if the scale factor is 4. So what you do is you take each one of your ordered pairs, you're going to take each coordinate and you're going to multiply it by the scale factor. And in this problem, what is the scale factor? 4. So we're going to have 0 times 4, and the other one is also 0, so that one's going to be 0 times 4. And what is 0 times 4?
0.
So this one remains 0, 0. The only time the coordinate will remain the same, and if you multiply by it, is when it's 0. Okay, so A prime is still going to be at 0, 0. Now let's go ahead and look at B. B is 8, so we're going to do 8 times 4, and then 0 times 4. And what is 8 times 4?
32.
32. So 32, 0 will be that new order pair. Okay. And then last, go ahead and try C on your own. Let's see how you do with C. So Camden, what did you do for C?
Times 3 by 4. And negative 2 by 4.
Okay, so you multiply both the x and the y coordinates by 4. And 3 times 4 is 12. And negative 2 times 4 is negative 8. So there's our results. So if we graph these three ordered pairs, we will label them A prime, B prime, C prime. Would this be an enlargement or a reduction?
Enlargement.
Why is it an enlargement? Because K, the scale factor, is greater than 1. It's going to get bigger, right? Because I multiplied everything by 4. Okay. Any questions about that? Then next, for example number 2. So the figure has vertices of J, K, and L. We want to graph it, and then we want to do a dilation. So let's first of all graph our pre-image. So we're going to label them J, K, and L. J is to the right 3 and up 8. K is 10, 6. And L is 8, 2. Ruler. we want to do this with a dilation of a scale factor of 1/2. If the scale factor is 1/2, is this going to be an enlargement or a reduction?
A reduction.
Reduction because it's between 0 and 1, right? So the new triangle is going to end up being smaller. So we're going to have J prime, K prime, and L prime. Since our scale factor is 1/2, we're going to multiply 3 times 1/2 and 8 times 1/2. 3 and 8 were the coordinates of our original J. What's half of 3?
1.5.
1.5. So this is going to be 1.5 and half of 8
4.
is 4. For K prime, we're going to do 10 times 1/2 and 6 times 1/2, which will be 5, 3. 1/2 times 10 is 5, and 1/2 times 6 is 3. And L, it's going to be 8 times 1/2 and 2. Fifth graders, I tell you. How'd it go?
Great.
Anybody got any questions about getting them? Okay, now let's draw them, and then I want to show you one thing and how you can check to make sure that you're correct. Okay? So we're going to graph J prime, K prime, L prime. So for 1.5, you're just going to go over 1 and then a half, up 4, 5, 3, and 4, 1.
But it's not the same size. It doesn't have to be.
And why won't it be the same size, Sharon? Because it's a reduction, it's,
Mhm.
yeah. So, does it still look like the same shape triangle?
Yeah.
Yeah, it didn't change it to a different triangle, but it definitely got smaller. Now, one other way that you can make sure, because sometimes it could look similar, but it may be a little bit off. One way that you can make sure that you've done this correctly is you can kind of just eyeball it. I'm going to actually draw my line just so you can see it happen. You want to see, you should be able to take your ruler and draw a straight line from the origin through J and J prime. So you see how those line up?
Mm-hmm.
So a line would go through those. The origin K and K prime. And then the origin So do you see how I can draw a line through J and J prime from the origin, and from the origin through K and K prime and L and L prime? That tells me that it's still a congruent triangle. Or I keep saying congruent, similar triangle. Sorry, it's not congruent. Okay, you don't have to draw those lines, but just eyeballing it with your ruler and checking to make sure that it really does go through all of them will help you to see that it's still similar. Okay, is that all right so far?
Mm-hmm.
Okay, last one then, let's flip to your next page. And for this one, it says through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. So the diameter of the actual grain of sand is 0.25, a quarter of a millimeter. You can't even see that with your naked eye, right? But when they enlarge it underneath the microscope, it appears to be 11.25 millimeters in diameter. We want to know how much was it enlarged by. So have you ever used a microscope?
Yes.
Okay, and so there's that little scale on there, and you can adjust it, and you can say how much you're enlarging it by, right? So we want to know what was that enlargement factor. So for these types of problems, it's always going to be the diameter of the dilation divided by the diameter from the original. The original always goes on bottom. So the dilation was 11.25, the original was 0.25, and when we divide that, we get 45. That means that this grain of sand was enlarged 45 times to be able to see that diameter at that size. So the scale factor would have been 45. So if you have both the sizes of the pre-image and the image, you can divide the two. It's always image divided by pre-image to find your scale factor. Okay? Are there any questions about anything that we've done here? Okay, then, Jerry, you can go ahead and turn off the video recorder, please. And I'm going to have you guys do some practice problems to work on this.